Hello and welcome. We've got an awesome webinar lined up for you today. It's a really exciting topic and we're going to be diving deep on some of the technology that's going to be powering the demo. Joining me today, I'm Nick Walsh, but I'm joined by...
Chris Blackwell. Hi, I'm a senior SDE here at Amazon, also a developer evangelist, and we're going to be walking through some interesting stuff today, showing a little bit of a game that we put a game that we didn't put together, but that we've added our code into. And just to give a real nice basic introduction as to here's how you get started with Aurora, here's how you get started with Dynamo. We'll show you how to actually access that from within Unity code. We'll be showing how to set the tables up, how to do some queries and stuff like that. So hopefully you'll find this interesting.
Yeah, so some fun stuff. We've got a boilerplate first-person shooter game that we're going to be showing how to add metrics and logging to. As far as figuring out if this webinar is right for you, our approach was to take a game that could be simple to understand and maybe different than your game, but to show you how to provision these instances and these cloud resources, these cloud databases that we mentioned, provision them, add the code to your client to be able to access them, and actually see how quickly and easily you can do this using AWS managed database services like Aurora Serverless for a relational database, or with DynamoDB for a non-relational key value document type store.
Yeah. In fact, one of the things that actually makes this pretty easy is that a lot of work has gone into putting really nice APIs together for these two services. So one thing that we'll be doing on the Aurora side, which is relatively new, is using the data API. So as opposed to having to use like a SQL connection library and get like a VPC set up and all these kind of things, Nick's going to be showing how to actually just call through the AWS SDK just like you would most other services and directly do queries and things like that. So it's kind of a cool service. Dynamo's kind of had that from the get-go. It's how it works, but we'll be showing some how to use that, as well as how easy it is in the console to do things like put together queries, which is actually both Aurora and Dynamo, and then translating those into code. So I'm going to let Nick kind of start off, because I think we'll be talking about Aurora first, and then we'll move on to Dynamo. But I think first we're going to see this awesome demo.
So without further ado, I figured we could jump into the demo to give you a taste of what we actually built, and then we're going to sort of unpack how the sausage was made and show you how you can implement this into your game as well. So before I get into it, this is essentially the Unity editor. Regardless of what game engine you use, this is going to be able to execute our code and build our game code. And we've integrated the client code to reach out to AWS along with that. So if I hit play, it's going to launch me into my game. This will take just a moment or two to load up. And to give a little bit of background on this game, it is again a first-person shooter. We've got two main objectives here. It's to eliminate all the enemies, primarily in the form of these smaller enemies that we'll get to, and we'll see them in this room right over here. And then there will be a boss later on that we need to destroy to beat the level. And the two things that we want to log from a game developer perspective are going to be the number of kills on enemies that we've gotten throughout the game, as well as some sort of score for completing the entire level. We're going to use a different database for each of those, but let's walk through the game. So I turn this corner here, destroy one enemy. On the lower right, I have my ammunition. I take some damage as they shoot me. I can get the health pack. Wonderful. So nothing over here, just a blank room. We run down here, and looks like we're going to find a boss.
The big bad boss.
The big baddie. Does a good amount of damage, and we eliminated the boss. All objectives completed. And so we see here some stuff getting spat out the console. Yeah. This is some logs so that we can see that everything is working as intended. But essentially that's it. A very simple game, regardless of it whether it looks just like this or not. The point is that you have certain events and metrics that you want to log to some sort of persistent data store outside of a game session. And that's where these databases are going to come in.
One of the things we should talk about is when we're looking at the code here, especially looking at the Unity code, we actually are calling these APIs directly from client code. Now, this is generally something that we don't recommend. We're doing this just for the purpose of the sample. Typically, what you want to do is have, if you have a server, your server will be calling these APIs, or otherwise you would create some kind of a simple web service that could actually handle these APIs. So when we get to that part, we're going to kind of it's sweep it under the rug a little bit, but we want to make sure that that's really clear, is that this is, although we're showing you how to do the code, this is not what you want to do in practice. And that would be, fortunately, it's probably a whole nother video to talk about creating a web service like that, but that may be a topic that we could address at another point in time.
Yeah, and one thing that we will do here is actually show when we're digging through the code the common pitfalls pitfalls for what would go wrong if you were to implement it exactly in this way. Again, we're trying to eliminate most of the variables to teach you specifically about databases here. But whether you're just trying to implement this for the first time or maybe you don't know much about databases at all, these are not problems that are rare. If you're using these for the first time, people can and have been burned in the past. So we'll address sort of preemptively what those are so you can learn from the mistakes of people that have come before you. So awesome, that was our game. We'll go back to it in a little bit, but next we're going to show you a little bit about the code for what we actually added, and then we'll show you exactly how to create those resources on AWS. So inside of Unity, again, it's this interactive GUI and environment editor, as well as sort of runtime to show us all of the console logging. But additionally, we can just open that code directly. So one of the things that's very important here in this boilerplate is going to be like the game flow manager. The game flow manager is this script that's running sort of as on a tick-by-tick basis that will assess sort of the game state and perform checks and do certain things if certain situations or events or prerequisites are achieved. So like if all enemies have been destroyed, please end the game. This would be one common example.
Yeah, if you're familiar with game programming, but not necessarily with Unity. So Unity actually runs its own game loop. This is hooked into their game loop and basically gives the sort of game state management, which is why we put our initialization here. It was the most obvious place to put it.
Yeah, so when I was thinking about the part that I wanted to implement, which was logging every single kill directly in some sort of incremented counter, think of maybe having a leaderboard for whoever has gotten the most kills in a game. What I had to think about was, all right, well, where does this event exist in my game? And so typically this will be maybe on the death parameter. Let's say there's no way for enemies to maybe die of causes outside of a single player killing them. Maybe this is, even in a multiplayer game, you can then have an ID of the person that destroyed the enemy as a part of the input to determine where you're routing this. So in short, I went to Unity, I went to the boilerplate, and I found that there's an enemy controller script. So I've found this here in my editor, and so what I'm doing here is I'm using the Amazon RDS relational database service. That is where Aurora and Aurora serverless database services fit under in terms of the AWS offerings. So we import these at the top. These are just using the .NET or the C# AWS SDK. And then all of this is already boilerplate code that exists for controlling the enemies. I don't really need to touch or manage any of this. It's doing things like visual effects for when the enemy dies. But what I really care about is figuring out what happens on death. So if I search for on die, I find this method here that's called, and it does obviously some things that are very valuable, but I also want to be able to execute some sort of request to update and increment the kill counter for my user that's playing the game. So here, this is actually all possible because of the data API we talked about before, but it'll make a little more sense when we look at it in the console in just a little bit. Essentially what I'm doing is I'm starting an asynchronous task. Again, asynchronous because if it were synchronous, it would create a blocking call that would actually stop my game from proceeding to further ticks whenever we do an update. This is an asynchronous threading task here, and within that task what I want to do is reach out to my Aurora serverless database, perform a SQL query, and essentially continue on with the rest of my game. So here with the data API, Chris mentioned it before, but traditionally you'd have to have some sort of JDBC connector or a proxy for your database where you'd send an HTTP REST call to your proxy, and then that proxy would manage the connections to the underlying database. Now the data API with Aurora Serverless actually enables you to send native SQL strings and queries directly to an HTTPS endpoint that automatically handles those connections and connection pooling to the underlying database. It's a super cool feature. Yep. Dynamo's had it, but for anyone who's worked with SQL and relational databases, it's really a game changer.
Yeah, in fact, I not having been very experienced with the databases before I came to Amazon, first time I set up an RDS database, before this existed, this data API, I spent about 15 minutes setting up my database, and I spent 4 hours trying to figure out how to get the JDBC to actually connect to the database. Yeah. So this is a huge time saver, and just makes it much easier to configure and get up and running with these kind of queries and stores in your code itself. I'm really happy to. This has only been around a few months now. At this
exactly.
point.
Yeah, and again, these relational databases as managed service have been around for a while, but this is a fairly new feature. And there's another really cool workflow that this data API enables us to do in the console in terms of performing queries without actually writing any code. We'll see that in just a little bit. But essentially here is a method that will perform the SQL update. So what this is doing is updating my table, which is called stat tracker, and I'm setting the kills column or parameter for kills +1, so a basic incrementer where user ID equals 1337. I've hard-coded this in here because I'm just running this locally, and maybe my game only has this one user. But essentially, when you start the game or a user logs in, this would dynamically, ideally, pull their user ID so that this database query was applicable for the stats relevant to that player. But again, for the sake of brevity and clarity, that's what this is here. We have some ARNs here that will enable us to identify the proper database to make this query for. And that is basically it. So I define the asynchronous method, and then I run the database update here and catch any exceptions where possible. And so really in what is 365 to 390, 30, 25 lines of code, I have now, from my client, any game that you may have, added the ability to log a metric, and I only logged one here, but if on death you want to log a myriad of different things like the XY coordinates or XYZ coordinates of the unit, any other sort of telemetry data, that's all possible. You just add some more content there in the SQL query. But that's basically on the client side. It's actually pretty straightforward, and the SDK again abstracts a lot of the the ugly underlying JDBC stuff. But let's actually see what it looks like to put this into practice in the console.
Can I put you on the spot for just a second on
Go
this?
for it.
I actually had a question when I was looking at your code. One of the things the Dynamo API offers is that there's an async API that's actually built in. I noticed that you're using the async separate here. In the data API, do we not have those yet, and that's why you're using the async code? Because you'll see a little bit of a difference between how you're calling it here and how you're calling it in Dynamo.
Yeah, so in terms of Dynamo, you're referring to like asynchronous uploads, like the method is inherently asynchronous?
Yes. Yeah.
Oh,
like
interesting.
It calls and does the await itself basically internally in the API in the SDK.
Yeah. So some methods in AWS SDKs have both synchronous and asynchronous methods for either like get items or puts for items. I'm not sure if the data API actually has an asynchronous way to do that built in. So I've basically wrapped what is a synchronous method in the local asynchronous sort of task.
Which is great. It's actually good to show this because you'll also there's multiple levels of APIs often inside the AWS API, and sometimes you want the control while you're doing the threading yourself. I'm actually glad that you wrote it this way. I just wanted to point out an interesting difference. Is you'll see that when we get to my code, is that I use a different style of API, but this is great to show how to use it's actually a not relatively new C# feature as well that actually have the await in here. It makes it much easier to do this threading code.
Yeah, and one other really valuable call out here is in the way that this was implemented. Again, if we aren't going to be putting our direct SQL queries and our credentials and our secrets all directly on the client here, we will want an asynchronous stub that even though I may not have my SQL code here directly, that may reach out to code that I have on a proxy like on AWS Lambda or through an API gateway that calls a Lambda. And so this call out to that Lambda should still be asynchronous, even if the code on the Lambda, like I have here, the method call is inherently synchronous.
Yes, yeah.
And I know we're making a big fuss and a big deal about this synchronous asynchronous thing, but when it comes to game development specifically, if you imagine that your game state has to proceed on a tick-by-tick basis at a certain number of ticks per second, this is really important because even if a database call takes milliseconds, if it is a blocking call in that other code cannot execute while you're waiting for a response, your entire game essentially freezes until that gets through.
You get those hitches, and we all know those hitches where we're trying to eliminate. So it's very important to think about the asynchronous calls and using those correctly in your games. Good call out.
Awesome. So let's actually dive into the AWS console. We're going to show you how you can build out and provision the database that will power this functionality, assuming you have no database expertise or anything set up in your account that's pre-existing. So what we're looking at over here is home base. If you've used AWS before, this probably looks very familiar for you. So what we're looking for Aurora Serverless, which I mentioned before falls under RDS, will be the RDS Relational Database Services console. From here, this is going to be sort of your single pane of glass into everything from your databases, query editors, performance insights. But what we're most interested in is creating a database from scratch. So what we can do here is we go to create database, and we get a handful of options, standard create versus easy create. I'm going to leave it on standard for now. so that we can explore some of the options. We have various engine types. So with RDS, you can choose to migrate. Maybe you have an existing MySQL database that runs either on premises or elsewhere, and you may want to port that directly. You can use MySQL bindings, Postgres bindings directly, and so on and so forth with these other options. But the option I went with, and that I know many other developers go with, is actually Amazon Aurora as the engine type, because it has compatible bindings for MySQL or for Postgres, but you get the additional scale out and scale up benefits by separating storage and compute in terms of basically only paying for the value of what you're getting and not needing to scale incrementally across nodes on a cluster.
Yeah.
Amazon Aurora also has the ability to be serverless, which in a relational database world is fairly rare and
pretty nice. Again, makes it easier to set up. It's also blazingly fast, if I understand correctly.
Yes, the scaling up in terms of not having to manage it's not sharding, but spanning your tables across multiple nodes on a cluster is fairly difficult oftentimes. And with Aurora, you don't have to worry about that at all. All the underlying infrastructure and the instances that your database lives on that cluster are abstracted from you, and that makes it significantly easier to scale up and down and to predict capacity.
That's cool.
So we're going to go with that one because that sounds very exciting to me. As I mentioned before,
Nick's getting these details. I'm not the database guy. I'm the game guy. So it's like, woo, okay.
Well, for today, you're the Dynamo guy. I'm just the Aurora guy. So we'll figure it out. But we're going to start here with MySQL. Again, if you prefer Postgres, go right ahead with that one. You can choose from any of these formerly supported version sets. I just went with this most latest one. And as far as the database location, you can choose either regional or global depending on your needs. There are associated cost and latency trade-offs if you need a global variant for that, but regional should do just fine for us for right now. As far as the database features, this will basically decide what the distribution of nodes on the cluster or basically what the nodes on the cluster will be. And so in our example, we want to actually abstract all of the stuff under the hood as possible, or as much of it as possible. So we're going to go with serverless. Again, a very rare option, but it fixes a lot of problems that we would otherwise face. So we can name our database right here. We can name this something fun like AWS Game Webinar, AWS Game Webinar DB. Nice and creative. We can create a master username here. This is going to be named, let's say, admin, but you can name it whatever you want. You can auto-generate a very secure password that will be stored somewhere on the cloud for you, or you can manually define a password here. So this could be like super secret, awesome, secure password. And then what we do want to note here is that, again, with a serverless sort of implementation, we still have these things called capacity units. So even though we're not thinking in terms of individual quantized blocks of servers that have X amount of compute, Y amount of RAM, and Z amount of storage that we scale up and down in integer quantities. Instead, what we can do is we can select the minimum and maximum that we want for our underlying database. And this is going to be contingent on what we anticipate our workload to be, and it will handle the auto scaling up and down within that range. It's good to sort of set these bookends to figure out or to guarantee that your database, due to a bug, may not explode in sort of in cost or in utilization. We can leave these as is. Again, the more important one is that the minimum is very low, because if we have low utilization, it will probably stay at or slightly above the minimum. Cool. So additionally, for auto scaling, again, instead of having to manually write out policy there, we can click to force auto scaling. We can pause compute capacity after consecutive minutes of inactivity if you're looking to save more money, or if this is maybe in like a dev scenario instead of production. We can just leave this as is. And then we have VPC settings for the virtual private cloud that our cluster or cloud resources will live within. I'm going to go with the default VPC for here. We have some additional settings down here, but the one that we're most interested in here is actually the data API. So I mentioned it before, but it now takes your MySQL database powered by Amazon Aurora and fronts that with a data API proxy that enables us to directly query that data API, and it actually handles, in any sort of scale up, scale out, or failover scenario, service discovery between the API and the underlying database. So you don't need to know that my database lives on these IP ranges and then my API has to talk to those IP ranges and any of that nonsense. You have a persistent HTTPS endpoint, and regardless of the state of the underlying database, you can continue to call that data API and it will handle everything else further downstream.
Yeah, and it's good to don't forget that one. That's sometimes I know I've clicked serverless. I'm like, oh, serverless, I'm done. But you got to go through all these default options and then go to the very bottom and turn on that data API. That's a good one to just don't forget to do that.
One other really cool thing actually is that if you do forget, which is very common because it can be a little hard to find here, is actually once you've already created your Aurora serverless database, you can go back and actually enable this after the fact.
That's great. As long as it's serverless, you can do that. I didn't know that.
Yeah.
That's good.
Exactly. So if you forget, or maybe you're already just using Aurora serverless, and you then want to add this later on because it was, again, just released fairly recently, you can do that.
Today I learned.
Yeah, fun stuff. Always new things here at AWS. So just make sure I have my database name copied. So we have all of our settings done. I think that took about 5 minutes, and then we're going to click on Create Database. So what this is doing is under the hood, we've got little hamsters on the wheels, provisioning the database under the hood, and so this is going to spin up the relevant instances, load up any sort of the parameters and feature sets. It will instantiate the data API that we wanted, and we can see here the status of this current creation job. Right here it says creating, fairly intuitive. I have a bunch of other databases that I've created here, including one that's actually powering the demo that we already did. So we're going to do the classic cooking show sort of trick where we showed you directly spinning up this database, but instead of having to wait around for it, what we're going to do is we're going to look at the one that we've already created with all of the exact same settings and see what the state of this looks like.
And we'll pull out our tasty Aurora database. Yum.
Yeah, exactly. Oh, beautiful. So we can see the endpoint here. This is going to be the endpoint that the data API, because it is enabled here, will enable us to send our HTTPS REST calls to. We have the port number as well. But what the data API enables us to do now is actually send queries directly in the console. And I know, again, in Dynamo, this has been a core feature for a while. But what we can do is we go over here, we sign in with our administrator credentials, and we get a native SQL query window. And so I have a handful of SQL queries sort of saved here on the side. Let me pull those up really quickly. Oh.
And while he's doing that, as a developer, I've actually found this to be really handy. So certainly with any SQL database, you can set up tools that will allow you to do test queries, but it actually involves you, again, setting up all these tools locally, setting up any kind of database connections you need. It's really great to just be able to go right in the console and build these queries and then put them in your code, because it's really nice to be able to test a query before you actually implement it, right? Nobody wants to build stuff, and then you're like, oh, okay, I got to build my code, debug, build my code, debug. No, you want to build these queries and then translate them to your code.
Yeah.
And this is a great addition, allowing you to do that right in the console. Don't have to have any additional stuff. So I really like this feature.
Yeah, so I'm going to show you exactly, this query is going to pull up the database and table on this cluster that was powering the game, and then we're actually going to show you what it means to create a database on this cluster from scratch using the same cluster. So we run this using my game data table, which is where my game is reaching out to. Select star from stat tracker should pull all of the entries on my stat tracker table. So what we can see here is I have a handful of users, and those are going to be each of the entries. Your user ID in this scenario is going to be the unique primary key. Then we have some other relevant information for each of these users. Think that you may have a database that stores multiple pieces of data. So it may do everything from logging the data directly to actually pulling the username to display in the console when they load in after they've signed into the game. So we have some names here. This is my Twitter handle. If you like this type of content, follow along. I talk about it all the time and make announcements there. But we've got some other familiar faces down here. We also have the thing that we cared most about, which was kills. I didn't track wins in my example. I have sort of a placeholder variable here, and John Carmack did quite a few test runs here in dev, but we're actually going to be testing our scores once we've won over in Dynamo in the other example. So again, if I play this game, each time I get a new kill, we see that this is 42. We can actually pop back over to the game, run it, and pause it as soon as I get a kill, and we should see that updated directly here in the console. And once we see that that's all working well, we're going to showcase how to do that from scratch. Okay, so I'm going to pause my game here for a second. We're going to flip over to Dynamo, or to RDS. We're going to run this, and this should go up from 42 to 43. 1337 was the user ID we saw in the SQL query in the console before, and that is still persisted here. So, exactly, this is the database and the data set that's running under the hood, but let's show you what it looks like to actually create your own database. So once you've created your own Aurora serverless cluster, you may not have any data. You haven't populated that yet. So what we can do is as follows. I'm going to jump over here, and I can create a database named whatever I want on the Aurora serverless cluster. I know that verbiage may be a little it sounds duplicated, but it's just similar words for the cluster is the infrastructure. The database itself on the cluster is going to be the entity you're directly interacting with. So let's say my database here is going to be called FPS kills or something. Copy that, run this. Oh, sorry, that's not valid syntax, so I have to name that as such. Again, you actually can create resources, not just view them here. So, all right, I've created that database. Next, I want to be able to create a table within that database to be able to define the columns and the parameters for each of those. So here, I'm going to be using not my game data, but FPS kills. And then I'm going to create a table inside of here if it doesn't exist already, so that we're not overwriting if we accidentally ran this again. And we want a few things. We want user ID as an integer. We want name as characters. Kills is going to be an int, and wins should be an int as well. So if we run this, it should use the FPS kills database and should create a table within that to do this, and we get the success here. Again, this is typically something you could never do in the console. You'd have to write SQL queries that would connect to the database and have a JDBC driver and do all that. So really cool, we can do all of that here. And now that we have our table, we're going to want to populate it with some data. So using this, we have some sample data that we're going to load in here. You may have this in like a CSV, or if your game is fresh, maybe you haven't done this. Maybe you create a user in your database on account signup. Probably a pretty common flow there that may have zeros for all of the values. So again, we'll change this to FPS kills and insert into this table all of these values. We can run this, and we see that both of these were successful. Again, you see the durations here on the side, extremely performant, 100 milliseconds, 300 milliseconds. And then lastly, what we're going to want to see is make sure that all of that data in our database is as we assumed, because we haven't gotten errors, but let's do a quick gut check here. We take a look, and we return all of these values. I was using my game data. Let's do FPS kills. Right, and so we see that these tables are inherently independent. We have 0 kills here, and all of the kills we were doing during our tests haven't obviously applied here because they haven't been updated. And then this one code sample at the bottom that handles incrementing is the same one that we have directly in our client code. So I can enter this here and show you that it will directly increment the kill count for the given user ID. And so this is actually how I developed the code. I sat here in the console, I created my database, created all these resources that are typically one-time setups, and then I tested the query directly to see that it behaved the way I wanted before I even went into my IDE to try to integrate it into my code.
Great. Yeah, that's a very similar thing that I use when we go to the Dynamo portion. I do that as well.
Yeah, a lot of the value is not just in the underlying technology, but in the interface to which we can get it to work well. I mean, you said you created a database easily in the past, but could spend hours trying to connect to it and get it to do what you wanted. So great. So this update request worked, and then we're going to go back and select the query here that will look at our table. And I apologize for all of the tabbing back and forth. It's very difficult to talk and think and write SQL at the same time. But here we go. It updated just like we expected. And in reality, that's sort of it. We've just walked through adding the code directly to our client using the SDK. In this case, it was C#, but regardless, you could have any of the AWS SDKs in language of choice on your compute layer there that execute these queries. And we, from the ground up, from scratch, created an Aurora serverless cluster. Took us about 5 minutes. We wrote some simple SQL statements through the data API in the console directly to be able to create our database on the cluster, create the table with the proper columns, add some dummy data that I've hard-coded, and then actually run those incrementing scripts that would then be used on the client side.
Yeah. So one thing I want to point out actually that I think is interesting to know, when Nick was initially putting this demo together, and I kind of actually added on to what he was working on, you had an intention for this demo, which is this is going to be a front end for something else. And it might be worth talking about that to understand why you want to track these kills live. Because as you see when you get to the Dynamo part, I actually also record the kills, but I get them at the very end. So what was your sort of motivation for putting this kill database together in the first place?
Yeah, so I mean, if you're a game developer, you want to track these things to do things like leaderboards and beyond. But I think one thing that we didn't discuss a lot, the sort of dovetails into the Dynamo conversation is the idea of like, well, which database should I choose? I didn't really address that in any of the Aurora serverless. And so when I was thinking about another part of a game, I was thinking actually about something along the lines of maybe like an auction house or trading, where you have a very sort of dense data set where you have items and they have properties. And for an auction house scenario, maybe each of those columns has to be non-null, and every item inside of that data set or inside of that table needs to have the same values. So that screams relational database model. And I ended up pivoting down the line in terms of demoing a kills showcase here. And Aurora serverless for this sample or relational database ended up working well and is performant. But when I was thinking about my access patterns, even separate from my data modeling, I was thinking, if I'm typically performing updates on a single key, maybe a relational database may make sense for storage, but not for access patterns, and maybe something like Dynamo could make sense. So, we have this like ongoing conversation as developers of, there is no one-size-fits-all database, whether it's from just a data storage perspective and a modeling perspective or an access pattern perspective. You typically have to balance this sort of, this game, the local minima of the two in terms of latency, cost, and developer experience. And so, this worked for me, but if I want to add more values to this down the line, for example, I may have to add more columns, and as my data set grows, that may not be as performant.
On the other hand, one of the things you're doing here is you're kind of capturing real-time metrics, which is an interesting use case here. Especially a lot of data analysts are very familiar with SQL queries, and you have a lot of flexibility in terms of the kind of queries you can do here. And you'll see that there's maybe a little bit less flexibility on the Dynamo side for the kind of queries you can do. So if we're doing something like this where you're actually trying to capture real-time game data, this makes a lot of sense because you can create those columns. You can do all kinds of strange queries with, you can do, I'm going to use probably the wrong, like foreign keys. You could have multiple databases. You can do these joins. There's a bunch of kinds of queries you can do that are much more suitable for SQL than for Dynamo. And we'll see why in a little bit. But I think this is actually a great example of, hey, this is a good choice because I'm capturing this stuff real time. I want to do these queries across my database in real time, and I want to see like what's the state of the game now versus like what's happening at the end of the game. So I like the fact that you chose this because it opens that flexibility up.
Yeah, joins are a really great call out here. So even if I have disparate parts of my game that require different types of data modeling and access patterns, if each of those independent ones can be modeled relationally and then I can perform joins, maybe I have like an in-round stat tracker like this, a table like this for kills and wins, but then maybe the auction house scenario I imagined prior is not thrown into this exact same table called stat tracker. Instead, maybe that's a different table, and with the flexibility of queries, I can perform a join on those two tables. Whereas in Dynamo, the ideal sort of scenario is that you really wrangle your keys to create ideal composite keys and throw everything into one table and architect that very well, which is a different set of skills than a lot of folks that are especially used to relational databases may have on hand.
Yeah, exactly.
Cool. Well, I don't want to toot my own horn too much. That's about all I had to show, but I think that was a quick and easy way to get started. But I want you to show off what it looks like to do tracking with Dynamo.
Yeah, so let's open up the Unity demo again. And actually, let's look at the code for that. Get you on the right screen here.
Yeah, there we go.
So this is all going to be implemented within the what was it? The game
flow
manager.
We talked about it before.
Sorry, I didn't remember the name. I was thinking game state, game flow, whatever. So Nick showed all we had to add at the very top here was just a couple of different includes for the DynamoDB. Why it's the DynamoDB v2 API, I don't know. I don't actually know what the DynamoDB v1. I think I might have looked at it a long time ago, but DynamoDB v2 is the one. Partly because what we have here is there's this object model. The document model. The document model, you'll see, will make it much easier to actually do your DynamoDB queries and item adds. I should note that one of the things that Nick did here, you actually can kind of see on the left, there's a bunch of AWS files. So you can actually grab the AWS C# SDK and drop it right into Unity, and it just runs. There's no mucking about. You literally just take I believe you just took it and popped it in your source directory, and you were good to go.
It basically just becomes source code that's bundled in with your game, and this is important for a game in particular because when you distribute that game, maybe someone installs it locally as an application. That code needs to be bundled in with the source code you've written. Otherwise, you don't want it to have to reach out to the web just to grab code that it needs to run the core functionality.
And I'll put a plug-in actually. Is there's if you search for AWS SDK Unity, you're very likely to come across something called the Unity mobile SDK. We've actually recently done a lot of work onto the C#, the general C# SDK, where I think the mobile SDK, probably don't want to grab that. It's a bit older. It doesn't have all the features you want. I would definitely recommend getting the standard AWS.NET SDK.
Yeah, that's
rather
what I
than
found
the mobile
for
SDK.
mine.
Yeah, so just something to keep an eye out for. There's still a lot of references. Any kind of searches you do on the web are going to show you the mobile SDK. Don't get the mobile SDK. Just go grab this AWS.NET SDK.
Wonderful.
Pretty straightforward. So, well, I can't point at the screen really, but yeah, there we go. So the first thing you're going to do with any kind of AWS SDK work is you're going to create a client, and the client's actually what's going to basically do all of the calls between your client and the AWS HTTP interface. Effectively, is how that works.
Everything has APIs, but we don't want to have to be manually crafting API calls
yeah, exactly.
with parameters. But instead, every language in the SDK has these clients that are really fluent in terms of interface with regards to whatever programming language it
exactly.
comes
So
in.
it's a pattern you're going to see all over the place. And so then the actual meat of what I've done is down in the update code. So I have when the game is, sorry, it's a little bit lower. When the game is ending, it actually calls end game, and this is when I actually do my tracking. So what I decided to do is I wanted to show a feature, we'll get into in a minute, called Composite Keys. And what Dynamo allows you to do is actually take a couple of pieces of data and combine them into one key. And I was thinking, well, what's actually a good application for that in games? And so what I came up with was, in this case, what I'm basing my score in is a speed run, effectively. And so my thought is, what if I wanted to see how I was improving in my speed runs over time? So what I want to keep track of here is I have a score, and the score is actually a composite. You can see it's the line right there. Yep. The score is actually a composite of how fast you played the game, and you get more points depending on the faster you run it, and then adds in the enemy kills. So of course in your speed run, sometimes your speed run, the challenge is to just get through as fast as possible. Sometimes the challenge is to speed run but also kill all the enemies. So I actually made it a composite score here.
Yeah.
And so what I want to do is I want to actually track my scores. I want to track them per user, and I want to track them per timestamps. The timestamps are basically Unix timestamps.
For when the user acquired
when
the
the
score,
user
like
actually acquired
during
the
the
score.
run,
Yeah.
time
So
of the
what I would be able to do eventually is do like a visualization for the user of, oh, here's a graph of how you're actually improving over time. So these composite keys are interesting in that the composite key has to wind up being a unique key. So when you have a composite key, that key has to be something that is not going to be found anywhere else in the database. So because we're actually recording a score every time per user, we can't just use the user ID. So in some cases we would be doing, like, let's say we're doing just a user profile. That would just be keyed with just a single key, which would be the user ID, because every user has only one profile. In this case, we actually have the user submitting multiple things, and we have to then decide, like, okay, well, what's going to actually make this unique? So what I chose actually was score wasn't going to work because the user could potentially have the same score.
Or two different users could also have the same
yeah,
score.
Yeah, but it would never be a case where you'd have, you couldn't just use score by itself. You can't combine the score and the user ID to become unique, because the user could have the same score twice. But the user hopefully can't play the game at the same time twice.
Well, and so this is like, this whole thought process comes from basically first principles, right? Like, you as the game developer have to think, like, what scenarios are possible and are not possible to craft the keys accordingly. So like an example here would be, like, let's say the run takes 3 minutes at the bare minimum, right? At barring glaring glitches, or even if there was glitches that they did it quickly, they couldn't perform the same game run simultaneously at the same time. You know that would be the case, that they couldn't play it the same, and that's how you arrived at that sort of situation. It may be like, okay, well, my user can't be signed in 2 places, so I know that wouldn't be possible, right?
Right.
All of these things go into that.
Yeah. So this is, you really have to think about your data model when you get into this, and it's a very typical thing. Is the first thing you do before you write any database code or put a database together, do your modeling, and then that'll inform you as to what is a good database to use. So in this case, Dynamo is actually a great fit because of the way it does these composite keys, and then B, what does my data actually need to look like? Or what do my keys look like? What do my tables look like? So in this case, what I'm doing is I'm actually combining the player ID and the timestamp for my primary key, because that's going to give me a unique value where every entry into the database is going to basically be those two values combined together.
Yeah.
Now, Dynamo, as we'll see when I create this, I'll talk about it then, but it has this concept of a primary key and a sort key, and so we'll talk about how that works.
Yeah.
So you can see in the code here, what I'm going to do is I'm going to basically load this table, and we'll see the table creation in a minute. So the table has just got a name, makes it really easy to refer to. We saw that in RDS as well. And then I create a new document, and a document is basically going to be the interface that I use to do all of the talking, or all of the data description between Dynamo and its API. So in this case, the document is going to just store an item, and this item is going to be saved in the database. And so you can see here that the item has our score, it has our timestamp, it has a user ID, and then there's a little magic I put in there, and you'll see what this is going to become important later. I put in a game version, and it'll be clear why that's important later. But the idea here is that if you're tracking your stats over time, it's very possible that game version updates will kind of invalidate what the speedruns are, because maybe you've added a more challenging part or
new content. Yeah.
So the speedrun times are going to be different, and so you want to be able to have the user see how they're improving in the same version as things don't change. So
we see something that's really common in games nowadays is like seasonality to like certain patches, or like they like you said, new versions, patches, or new like expansions that are released. You want to easily be able to filter and not have to figure out like, well, when did that game come out, and when did that patch land, and then let's take a window between these two like UTC timestamps. Like that's not ever fun to do.
No. That's
it's so much easier to just
but
throw
you
another
just have a version in there. Then we can make sure that we're letting the user or the player compare apples to apples as opposed to apples to oranges.
Yeah, and then one other call out here before you continue is basically like, whereas in my example you just saw one string that had a SQL statement, instead, because this is NoSQL and this is
DynamoDB, good point.
the document is keys and values. So this document is a local in-memory object, but this is going to map directly to the data structures that are stored in Dynamo for keys and values. So you have the key being score, and then the value for score, and so on and so forth down here.
Yeah, in fact, the document interface here takes place of there's multiple different APIs with Dynamo, and I don't want to be too confusing, but typically in the I would say like older or more powerful Dynamo API, you actually use JSON, and so in this case, this is actually just sort of making it easy for you not to import a JSON library or create a JSON string. But that's the idea here. Is these are keys and values. The keys are just the names that we're going to be using in our database for our queries, and the values are obviously the values that go into it. And
trading off in the flexibility of querying that SQL world sort of has. In NoSQL world, you can create these items that have inconsistent, like schemas or schema lists database. So, in one part of the table or one part of our code, we can input items that look like this, and in that very same table, we can have another piece of code that inputs objects that have entirely different keys and values.
That's a great point. Yeah, I could have all kinds of different data in here, and also I could take the same data, and let's say later on I want to just add new fields. I can do that, and it doesn't invalidate all of our data, or we don't have to go through and like populate extra columns of data with nil values or something because they aren't there. So that's pretty powerful. And then the very last thing here is just this is what I talked about, the little bit difference in the APIs here. We have this put item async. So this is one where, as opposed to having to put write the async code yourself, if you're okay using the asynchronous loop that's built into the AWS SDK, you can just use these. If you do need to be more careful with your with your multitasking, which especially could be the case if you're doing like a console game, that you might have some real hard problems around how it actually does multitasking. You may want to do something more like Nick has done, where you're actually creating basically a thread pool with the await. Here I'm using the async because I know on a PC and a Mac it's just going to work. It's basically the same code. So this makes it a little easier on you. There are blocking calls as well. It's funny though, when you type this in Unity and in the editor here, it gives you a little error if you try not to if you don't put. It's very clever actually. If you don't put this inside of an async block, it'll tell you that the blocking call looks like it puts a little warning, which is awesome. Like, it's like, oh, that's cool. Like I put this blocking call in, and it's like, oh, you should fix this by putting an async call in or wrapping it in an async loop. So
it's like a real-time linter, basically.
That was I was actually when I wrote that I actually hadn't seen that before, and I was like, oh, that's really cool. Thank you Unity for saving my bacon and not doing the wrong thing.
Yeah, and for reference, like I've never written, in games or in Unity before, and I understand some of those fundamental concepts, but that was very useful to me because I actually implemented it the wrong way at first, and I saw the first time I played my game, like, wow, my game froze for a full, half a second.
Yeah.
Why is this? And then I realized, oh, if this is a blocking call, and I need to implement that asynchronously.
Yeah,
so
exactly.
if you do have a call that is synchronous and blocking, I feel like you will learn it
you will
very
learn it pretty quickly. Yes.
Or hopefully you learn it before your players do. I think that's like the bigger one.
Yeah. So anyway, so that's basically how Unity connects in and is going to be writing items into our database. So let's go ahead and go into the console, and we're going to go ahead and I'm going to show you how we went and created this database. So unlike what Nick had showed you earlier, again, where you have to come up with a sort of structure ahead of time, the only structure you have to come up with is what are your keys going to look like. So let's go ahead, and you're in the Dynamo here. We're going to create the table. And then let's call it, let's give it just whatever we can call it. How about, let's call it FPS game. FPS game scores. How about that?
FPS game scores.
Sure.
Wonderful.
Yeah. And then the first thing you see it's asking you here is it's asking you for your primary key. So Dynamo has this concept of primary and then multiple secondary keys. There always has to be one primary key. And the primary key, there's a lot of knowledge associated with creating good primary keys. In our case, it's pretty simple because we already know what we want. But the primary key has a lot to do with how efficient the database queries are. And we were actually talking about, there's a fellow who is like the super database Dynamo guru who has he actually has all kinds of blog posts on how to create super efficient keys using, if you could have like multiple things that are hashed together, and it's really quite interesting.
Really quick plug then, I guess. So Rick Houlihan, he works at AWS, works really closely with DynamoDB. He gives a talk every year on database design patterns for Dynamo.
Yeah.
Definitely worth checking out. It is a dense talk. There is so much information packed, and there is so many new advancements and learnings and feature launches year over year that the same talk title carries over year, and the content improves and has new stuff each time. So definitely recommend checking that one out.
So what we're going to do here, when we create our primary key, is we're actually going to do, as I said earlier, it has to be unique, and so we're going to use our player ID, and we're going to use our timestamp. So what we're going to put here is we're actually going to have to expand this, and so if you see there's an add sort key. Add sort key is this, what I talked about, the composite key. So we could not have a composite key, and we could just have user ID, but that's not useful for us because we want to be able to have multiple entries with the same user. So the partition key is basically the thing that's going to kind of group together your keys into a logical space. So in this case, the logical space is our user, right? The user is going to have all of this different data associated with him. The sort key actually is very aptly named because the sort key is going to take the data that's within this partition and tell you how it's sorted. Well, timestamps make sense because the timestamps are sequential, right? Or they're in an order. So we want them actually sorted in a way that makes sense. So because we're going to show them to the user in that sequence, we're not going to show them randomly, right?
Yeah. So when we think about this, our access patterns are either we want to pull up all of the entries for a given user or all of their runs, or if we want to, sort and perform scans or operations broadly on the entire table, it's probably going to be when the run occurred.
Yeah, exactly. Yeah. So in this case, what we're going to do is we need to identify what our keys are, and we already did that by showing the keys in our code. The keys have names already. So our partition key is going to be the user ID, like we had in our code, all lowercase, and then our sort key. Oh yeah, sorry, it's going to be of type number. That was important. So user IDs could be. They might be a UID. In my case, they could be just an increment integer.
We know that there are scenarios.
There's all kinds of different things you want to do.
One example, actually, for AWS resources, sometimes it makes more sense to use a string because I know, for example, in AWS accounts, you can have not trailing zeros, but leading zeros on an account.
Yeah, that's a good point.
So a nice, just general call out, if you have leading zeros as a possibility in a totally randomly generated ID, those would get cut off in a number, but in a string, you would want to preserve the integrity.
Good point. I would normally have a user ID as a string, but in this case, I wanted to make it easy, so I made did a number.
My gut is always number because equivalence is like it's just more logical sometimes that way, but it's just better practice.
And then the sort key is going to be called timestamp, and this is literally a Unix epoch timestamp, which is just an integer, which is the number of seconds since January 1st, 1970, I think.
Since yeah, exactly.
Yeah. Okay, so that really is it. Now we've got our primary key identified. We can go ahead and create our database.
And I mentioned Aurora serverless like a bunch of times, like serverless, and how good that is in comparison to a lot of the traditional methodologies for deploying cluster. Dynamo is inherently serverless.
It is inherently serverless. It was never not serverless. So, and that's pretty typical of a lot of these NoSQL databases, I think, is they're I mean, even if you run like Mongo or something like that, it's kind of runs on its own and
yeah,
do that,
and what this really means here is that we just created a table, and it's available right away here. It's FPS game scores.
Yeah.
But essentially, this one table will scale out to any number of underlying instances. So if we throw a bunch of data at it, or we have a ton of reads and writes that require compute resources, we don't have to think about how our table is distributed across all these nodes on a cluster. It's just we have our table, and that's what we interact with. And there are these units called read capacity units and write capacity units, but those are essentially independent from the underlying resources that are powering them.
Yeah, which is cool. Definitely makes it a lot easier to work with. Oh, so now that we're actually in this in the table here, it was created basically instantly because the table definition literally is just the key. We could actually start creating items in here, which can be useful if you're thinking about your data modeling and you want to try some things. I'm not going to do it. I'm not going to bother in the demo to create them, but you can see there's this thing where you can create it visually, or you can create it as a JSON. You can add items. It's already created the two keys here for you. Any keys that you actually have specified, any fields you have specified in your keys are going to show up in this, which is kind of cool. So, but you could add random stuff as well.
Yeah.
So what I'm actually going to do is have Nick switch over to Cloud9. I'm a really big fan of Cloud9, by the way. Makes it super easy to work with any kind of like AWS console access. You spin one of these Cloud9 consoles up. You can run scripts. You can call AWS CLI commands.
Yeah.
You can do all kinds of. It's a very handy way to not have to bother setting anything up on your local machine to do a bunch of these like kind of general tasks you want to do with AWS.
I mean, it's a fully managed, persistent developer environment that actually, when you're creating it, you can choose the instance type. You can choose a really small one, obviously, because it's just reaching out to other services. But the point is, like, I've had many scenarios where maybe I change devices or change laptops, but if I can sign into the console, I can get into Cloud9 and have all of my libraries, all of my, like system variables set exactly how I expect them to be.
Yeah, exactly, which is really, really nice. It's just all set up for you. So let's change. Well, actually, we actually have this little script. I wrote the script that does some like fake data that we're going to populate. I'm not going to go into the script here. The interesting script is the other one, which is the Dynamo score. It's the Dynamo score test. This is a little, that's the JSON file.
Yeah.
Populate DynamoDB.
There we go.
The right one. So populate DynamoDB. This is a little thing I wrote that it's going to take this JSON file that I created, which is these fake scores, and let's actually,
which we see here. So
those are the fake scores that were created. So I ran the script, created these fake scores, did this all in Cloud9, by the way, and then let's change that table name to be what we just created.
Yeah, which was FPS game scores.
FPS game scores.
FPS game scores. Great.
You can even just copy and paste if you wanted to.
That's the more accurate way to do it. But
so I wanted to show this because this is actually kind of cool. So potentially I could have, maybe I want to do a test data where I have like thousands of items. In this case, it's only a few hundred. But this shows one of the interesting APIs of Dynamo, which is the batch API. So actually, this is kind of cool. C#. The API actually does all the batching for you. So if you have a bunch of things you want, if you have like a couple hundred items you want to do, rather than calling those the put item one at a time, which is going to take forever,
because each of those has an overhead.
Each of those has overhead. It has to actually call. It has to make an HTTP call. It has to get wait for a response. It has to put it in the table. The batch calls actually will batch up to 25 items together and do those puts all at one time. So it's a really nice way when you have these sort of massive writes to do that. It's also actually, if you're doing stuff like let's say I was collecting metrics data, and I wanted, I didn't want to be sending out a metrics data every time something happens. I instead want to queue those events up in a queue and then drain that queue. I would use this batch API. It would be a lot faster to actually update this data. So
It's actually a really good call because in
Yeah.
the way I implemented it, I was on a direct event as soon as it happened, logging the kill. But instead, what I could do is have a data structure that lives in Unity and keeps sort of like a running ticker
keeps
of
track
those.
of it and then sends
at the end of the round, and if you're facing performance concerns, depending on how this is implemented, maybe that's the better solution.
That's a good point. Yeah, I think yours might be a good solution for maybe when you're testing or something and you want to get that data live.
Or you need it
or you
exactly
need it
real time.
exactly real time.
Like
for
maybe
some
you're doing
reason.
an esport and you need a visualization somewhere of that real time data that may be like on a big screen or something. That may
but
be
oftentimes it's good to batch them, and you've got to kind of make that call. In some cases the data is like super sensitive. You have to do it right away because it could be at the end of a session you lose. Customer quits the game before there's a chance to send. So you have to think about those kind of things.
Yeah. Okay. All changes saved, right? So when I changed the name, I didn't save it. It was still calling out to the old one. So this is obviously
save your files.
And then just after calling that, we refresh.
Yeah, there you go. You see, it's already batching this data up in here.
And that was just, again, like a randomly generated user script. But a scenario where this actually becomes really important is, let's say you are maybe in dev, or you have another scenario in which you have a bunch of user data already, and you're trying to bring that in an integrated database, and you're worried about the lift to get your existing data in whatever format it's at into DynamoDB to actually start using it. And so, with a really simple script like we showed right here, as long as you have that data in JSON or key value format, you can write 10 lines of code just like you did here, and we can actually batch load that directly into Dynamo.
Yeah, very, very handy, very handy. Let's pop back. So one thing I want to show you here is we were talking about being able to do the queries and build your queries actually right from Dynamo, the Dynamo console. So let's do that since we're here. So right now we're actually in scan mode. What I want to do is I want to be able to actually go into the query mode, which you can see there, and then it'll nicely bring up all of the key values. So let's do a query to see like, no, it's actually I had a little script I put together myself here. So let's change the user ID to 1 and use the equal sign, which should show. So user ID, put the value as 1. And then let's change the equal sign on the timestamp to greater than. And then put 1 for the value in there. And this just shows how we can build a query. And then start search. And you can see now it's bringing all of my timestamps that are greater than 1. And it just lists them in there.
Yeah.
And you can also change the sorting order. This gives you the ability. So you can take these queries and really easily translate them now into your code, into the AWS SDK. But have an idea of what you're actually querying before. And that's why I did the test data, I wanted the test data so I could actually make some real queries and see what they look like.
Yeah, and again, in the same way I was running my SQL queries directly in the console because of the data API, this sort of just helps you eliminate the variables. Maybe you haven't used a database before, you want to make sure that your query is performing as you expect. You can do that directly here in the Dynamo console without any other sort of potential interactions or subterfuge happening from rogue code not acting the way that you want. And so once you have this working in the way that you are as intended, essentially, you can then bring that to your game and have much more confidence when you're trying to implement it in terms of what may not be lining up as you expect.
Right. Now I'll do one more quick thing here before we go. I want to show a secondary index. So secondary index is, let's say that now we have all this data in here. We can see our values for a player over time. What if I want to go see who the top 10 scores are?
Very common use case.
Yeah, very common use case. So what we're going to do here is that everything in Dynamo is based around indexes. And the index is actually basically built real time as data is added. And it's constantly like going and basically rebuilding these indexes to get the latest data. So let's go into the indexes tab.
Great, is that up here?
Right there.
Yeah.
And then we are going to create index. So in this case, we're going to create our primary key. This is where the version comes in. So what we're going to do is we're going to call it version. And this is going to be a number. And we're going to be version 1 in all of our queries. And this is why I put this in, is that we need, so these partition keys always have to be some value that can partition the data. And so in this case, version makes sense because we want to be able to see scores within the same version.
Yeah.
And then we'll go at our sort key. The sort key is going to be score, also type number. And then you can see it actually creates an index name, which is what you would use in your code to refer to this index. So we can go and create that index now. And this actually does take a little time because it has to actually build this data. So once this is done, we can actually I don't know if we'll get it done in time here, but we'll see once this is built, we can go and query against this, and we can actually see, who are the we can say, oh, let's show me the scores that are, we can actually scan, we do a scan versus a query, and it could show us either ascending or descending all the top scores and all the bottom scores per user.
So we noticed there actually when we were creating it that there were base like read and write capacity units. So an additional fee to implement a GSI, a global secondary index. But the value proposition here is that by offering a different view of your data essentially with this different index key, that additional cost there is saving you the cost of having to perform more writes and reads on the base table and performing scans. Because the idea is that you want to craft these secondary keys based on the work, like how you're planning to index or access them.
Right.
And so you want to avoid a scenario where you have this non-relational model, but you're still scanning through every entry to see which ones.
You don't have to look. You don't have to like go through every 10,000 entries in your database to see what the high scores are.
And that's a complete anti-pattern. Like if that's what you're doing in Dynamo, you're
doing it wrong.
You're doing it wrong. It sounds like, and that it's not that it's your fault or anything. Like a lot of times when you're coming from MySQL sort of scenarios, the scan is sort of how you're introduced. So.
Well, I think we're out of time.
We are. I mean, we covered two really awesome scenarios of being able to add metrics and logging to your game, both with Aurora serverless and with DynamoDB. We hope you learned a thing or two from today's webinar. We've got a lot more exciting content. Again, Nick Walsh and Chris Blackwell here from AWS. Thank you for tuning in, and we hope to see you soon.